Okay, let's try these four questions. The last question on finding the tangent, defining the equation of the tangent using calculus here. The last question's done in another video I did a couple years ago, but let's just, I redid it again and on this one. But anyways, let's just start it. First question is, you're given a function, x squared minus x minus 6, and you're asked to find the equation of the tangent at x equals 0. Well, this is a curve. And right at 0, there's a point there. And if you push a line up against it right at that point, it's got an equation. It's a straight line. It's like pushing a ruler next to a basketball touching on one point. That's the tangent to the kind of like tangent to a circle. It's just a tangent to this curve. Well, what do you do first? First take 0 and put it in there and see that, oh, it's minus 6. So that's called the point where the tangent happens, the tangency. Okay, now it's time. We've got the point. We need the gradient. Well, that's what derivatives do. They tell you the gradient at a particular point. So let's find the derivative. Well, you go 2x minus 1. That's what this powerful little machine is for, telling you the gradient at any point. In fact, if I put 0 in there, I'm going to get a gradient of minus 1. And now it's just analytical geometry. You've got a point, you've got a gradient. You put the point of 0 and minus 6 into here, and you put the gradient there, and that gives you minus x, and then you subtract 6. There's the equation of the line. Let's try this question. Okay, it's exactly the same thing, except this is a cubic equation. 2x cubed. It's curvy all over the place. It's got a couple of curves in it. Anyways, at x equals 1, just put 1 in there, and you get 2. 1 cubed times 2 is 2. So 1 and 2 is the point they're talking about. What's the equation of the line that touches at that point? Well, we got to find the derivative, the dy dx, which is the same as f prime of x, and that's going to be 3 times 2, 6x squared. Then all we do is take 1 in there. We're going to get the gradient of that line just by taking 1 and putting it into the derivative. So what is that? 6 times 1 times 1? Oh, the gradient is 6. Then just stick in x is 1, y is 2, and the gradient is 6. That's minus 6. You add 2, you get minus 4. Okay, let's look at the next question. It's a little bit harder because I've got easy actually to put 2 in there. 4 divided by 2 is 2 plus 1 is 3. So 2 and 3 is the point of tangency. Now, but how the gradient's a little trickier here because we've got to make it x to the minus 1. 4 times x to the minus 1. We multiply it. It's minus 4 x to the minus 2 when you subtract 1. There is the derivative. Now we need to find out what the gradient is right there. Well, we take 2 and put it in there. What does this x to the minus 2 mean? It means 1 over x squared. So you just take 2, put it in there. Oh, 4 divided by 2 times 2, it's just 4. Hey, the gradient's minus 1. And then it's just stick minus 1 in for m. There's your x1, 2. There's your y1, 3. That's plus 2, and then you add 3. You get y equals minus x plus 5. Now the next question is quite a bit harder, and I think it is, because you've got to go root 3 times x. Well, the first thing's easy. Put 3 in there. 3 times 3 is 9. Y will just be 3 when x is 3. Well, there's the point of tangency, the point where the tangent hits this curve. Okay, now, but what's the derivative? Well, we're going to have to put this in the right form. We have to go root 3 and then x to the half. Then a half times root 3 is root 3 over 2, and then we subtract 1. There's the derivative. There's the derivative. But what does this x to the minus half mean? It means 1 over the square root of it. We need to find the gradient. 1 over. A half means square root. Negative means it's on the bottom. But hey, if we want to find the gradient right there at 3, all we have to do is put 3 into the derivative. So let's try that. Well, that's 1 over the square root of 3. Hey, those root 3's cancel. That's nice because the gradient's a half, and y1 and x1 are 3 and 3. So we just put in y1, x1, the gradient, and that's it. Minus 3 halves plus 3 is plus 6 halves. You could do it on your calculator. You get 3/2 or 1.5. And there's the equation of the line that touches at this one point. Well, that was a bit long, but there you go.